Okay, the whole of S1 in 25 minutes. I hope this makes sense. Obviously, don't just use this if you've never seen the chapter. This is to add to your chapters and work on a few exam tips. Good luck. Okay, chapter 1, mathematical modelling. I think you just really need to know that discrete data, discrete data, as you know, can be counted, number of people, etc. And then we have continuous data. And this is data that has like a range of measurements, okay? So we've got height, weight, blah, blah, blah. Now, advantages and disadvantages of models. You know that the positives is that they're quick and easy, and they help predictions. Not that I've seen any of this, by the way, in any papers. However, it is chapter 1, they might ask you. And then the disadvantages, sorry, I'm trying to do this fast, is that basically we are simplifying a real world situation. Okay, we're simplifying a real life situation, and it may cause error because we're trying to make real life simple. Okay, so we're trying to simple, and then it may only work in certain conditions. Okay, because we can't really, we're trying to reenact a real world problem with not all the variables. Okay, so certain conditions we will be able to do. So that's chapter 1 done. Okay, then we got chapter 2, measures and location of spread. So you should all know the mode most common, median is the middle, etc., etc. Okay, and then you already know about frequency tables. This is like a recap of GCSE. And then watch out, if this is 10 and this is 11, make sure you change this to 10.5 and then change this to 10.5. Okay, however, all of that stuff should be GCSE. Now, the lower quarter and upper quartile, I always say, when in doubt, count. Okay, you don't need to remember any extra formulas that you don't need to use. You can use your calculator for all of this. Something we have to remember, though, is there are some key things, and those are the variance, okay, and standard deviation. So we know that variance is standard deviation squared, okay? So we know to find the standard deviation, this is standard deviation, we need to do the square root. Now, I remember kindly, this is kindly from Dr. Frost, so the mean of the squares. So if I put sum of x squared over n minus the square of the mean. Now, this sum of the x that I'm having here, this could be, if it's grouped frequency, it could be xy. Okay, this could be xy, or sometimes they throw some t's in. Be sensible. Now, coded data. Okay, coded data for this. What you have to remember is that whatever we have, if y equals is our coded, and we have 4x plus 2. Okay, with our mean, we do it all. Okay, so we do it all. Okay, in this case, what have we done to x? We've times 4, then added 2. Great. So for our mean, that is what we do. For our standard deviation, what do? We only do the multiplier. Okay, so the multiplier stuff. So we only do the times or divide, right? Or, well, in our case, it'd be times like a quarter instead of divide by 4. We don't care about the plus 2s. And then for our variance, okay, we need to square it. So whatever it is, the multiplier that's affected x, we square it. I hope that makes sense. And I think that's everything for this chapter. Oh no, sorry, I forgot the most important thing about this chapter, linear interpolation. Linear interpolation. Guys, I'm trying to do this so fast for you. Okay, so linear interpolation. Remember, you have to find what position. Position is the most important when you're doing lower quartile, upper quartile, percentile, whatever you're doing. Now, I always like to do this method. Let's say our interval is between 10 and 14, and I know that my frequency is 12 to 20, and I'm trying to find the 18th position. Okay, where is 18 in here? 18 is roughly here, which is what? From 12 to 18, it's 6, and then from 12 to 20, 8. What I'm doing here is looking at the proportion. So technically, this proportion here is 3/4. So to find out where they are in the interval, I need to find out what is 3/4 between 10 and 14. We know that's 3. So where would this be in the interval? 13. So that's how we get our answer. I literally use common sense, okay? Have a look at my videos if you haven't seen this before. Okay, chapter 3. This one is representation of data. So a few things to take note of. Stem and leaf diagrams. If I ever ask you to draw one, make sure you put the key. For example, 1, this line, that is 14. Okay, so you know you've got your 1, 4, 5, 2, 2, 3, etc. Okay. Now, if they give you a list or anything, make sure you write down and you know exactly what's going on. Histograms, they always like to, in histograms, tell you, they'll say, you know, the width between 10 and 14 has a width of 4, but it has a height of 2, and you get 20. They'll be like, what is the other one when you have a width between 14 to 16? What's the height? Well, first of all, in this case, we can see that 4 is 4. Okay, so we know here that this is going to be 2. So I like to draw pictures for this to figure out what's going on. Now, in this case, I have 2 times 4 is 8. Okay, but we're saying that 8 equals to 20. That is what we're technically saying. This is how we're finding out what's going on. So what are we gonna... I think we're missing a piece of information here. Right there. Frequency 60. Okay, so if 8 equals 20, 2 times 4 is 8, we know that, but 8 equals to 20. So I need to know, what does 16 equal to? So if 20 equals 8, what does 16 equals to? Now you can do that cross multiplication, okay? 8 times 16 divided by 20 if you want. So if you do that, 8 times 16 divided by 20, you're going to get 6.4, okay? So 2 times what is 6.4? We know the answer is 3.2. So that is how we find our height. So I don't really have, this is the only way really I know how to do it. There definitely are other ways, but do what feels good for you. Something to remember in box plots, and people always forget this, is that with your box plot, each section is 25% of the data. 25% of the data is here, 25% here, 25% here, 25% here. Now, is the data skewed to the left or the right? So, what is skewness here? Again, I do not remember the formula, but what I know is the box plot, okay? If you look at these two different box plots here, what do we definitely know about this? Even though this is 25% of the data, I know that this section is smaller than this section. So immediately, quartile 2, 3, and 4, I could write the formula of quartile 4 minus quartile 3 is bigger than quartile 3 minus quartile 2. I can actually write that, okay? So you don't actually have to remember any of these. You just need to talk about the skewness. Now, with the skewness of this, what do we know? This is going to give us a positive skew, and this gives us negative. Okay, so just remember that. Then they normally always give us the formula if we're talking about the 3 standard deviations against the mean. They give us this formula to describe the skew, where it's like 3 mean minus median over standard deviation, they give you this. Literally, you know how to find the mean, you know how to find the median, you know how to find standard deviation. It's just substitution, okay? And the bigger the value, the greater the skew, okay? And I think that is everything we need to know for this. Just make sure, content, or context actually. Whenever they ask you to compare, relate it to the question. If the question is talking about how many bees are there in a garden, your answer should say the relationship between bees in the garden, etc. You need to make sure that you are relating it to context. Okay, now we're going to start speeding things up because we're given the formulas for pretty much the rest of the questions. Question 4, read the question. I know that sounds really silly, but read it, okay? And read it again. And make sure you know what it says. Then remember, probability is given. You have formulas in the formula book, okay? Please use them. Now, remember a few things. Mutually exclusive. What does mutually exclusive mean? So that means the probability of A union B is the probability of A plus the probability of B, okay? However, for, oh my God, I've forgotten the word. For independent events, okay? For independent, you know that the intersection of A intersection B equals the probability of A times the probability of B. Now, you can use this fact in the formula that you're given in the formula sheet if you ever need to, okay? Because in the formula sheet you're given probability of A union B equals probability of A plus the probability of B minus the probability of A intersection B. Okay, so make sure you keep that. Something that you have to do, make sure you write all the probabilities, what you're doing. Watch out for the words, or if they take a ball out, or if they add a ball out, etc. Now, also, if A and B are mutually exclusive, what do you know? You know the probability of A intersection B equals 0, so remember that. The biggest thing to remember here is that keyword. If it ever says given, okay, I want you to think denominator, absolutely, that's the first thing you should be saying. So if it says find the probability of A intersection B given A, that means the probability of A is your denominator, and then the probability of whatever you're finding is on the numerator. Or if you don't have it like this and you've got a Venn diagram and they say given A, this is your A. Oh, wrong colour. This is your A here. That means whatever probability you choose can only come from this blue bit. If it's given by this blue bit, you can only choose probabilities from this blue bit. Now, they have given you the formula for this as well, so if you have to go big on the formula sheet, you can. And then, this is supposed to be probability of B here. Given A is the probability of A intersection B over the probability of B. What else do you need to know? I think this is everything you need to know. Just, remember A dash means not A. Just use colours, read it twice. That's the best thing you can do, okay? Well done. And also, if the probability of A given B equals the probability of A, then this tells us if they're independent or not, okay? So that's another way. Sometimes you've got to make a few equations simultaneous. Okay, chapter 5, correlation and regression. There is not really much to say about this, but everything is given to you in the formula sheet. The whole formula sheet have this for you, okay? You have x equals sxy over sxx. You know that y equals a plus bx, where a is the mean of y minus b lots of x. You're literally given all of this in the formula sheet. If you do a few questions of these, you will always know what to do, okay? That's probably one of the easiest chapters. just remember that correlation, if it's close to 1 or -1, okay, the more like correlated it is. Obviously, if it's close to 0, this is more looking like no correlation, okay? 1 is positive, etc. Coding, again, R is never affected by coding, okay? Is not affected by coding. And this is, what is R, by the way? Our product moment correlation coefficient, okay, the PMCC. Another thing to note as well, if it's independent variable, that means it's plotted along the x-axis, independent. And then if it is dependent is plotted along the y-axis, okay? Coding, again, we can use coding. Remember with coding though, if we're coding for the mean, so coding the affects the straight line, you know, like the y equals mx plus c, what do they call it? Okay, coding affects this. Now, because we're using the mean, everything you have in coding you have to do, okay? Okay, discrete random variables. What do we need to remember? We know that when we have discrete random variables, sometimes they will tell us to make the table. If they do, well then go ahead and make the table. What do we know about the probabilities? Okay, probabilities, you know, all of these add up to 1. That is something that you should know. So that is when we do E of x, which is the mean, we would divide it. You know, normally you add them all up, divide it by the total amount, but we divide it by 1 here. So make sure E of x is your, like, whatever we're, I don't know, if this is like 1, 2, 3, we're multiplying that by our probabilities, okay? So you know that you're multiplying your rows together, okay? Then what do we know? If we're doing E of x squared, we've got to square these numbers first before we multiply them by the probability. Something they like to do is, you know that the variance of x is okay, which is minus E of x squared. You need to rearrange this sometimes, and that's okay. Remember, they like to do a lot of simultaneous equations. You might have to rearrange this. Remember this formula, it is not given to you. What else do you need to know? So the coding of E of x. Oh my God. Here we go. The coding of E of x, okay? Whatever we do in coding, we do the same to E of x, okay? So if our coded is y equals 4x plus 3, we're going to do 4 lots of our expected plus 3. But for the variance, remember, variance, we only care about the multiplier. What is the multiplier here? The multiplier is 4, and we're going to square it. So then our variance would be 4 squared lots of our var of x, and we don't care about the plus 3. So that's something that we need to know. The other thing is, if it's symmetrical, what do we know? If it's symmetrical, then E of x would equal our middle one here. And any other tips for this one? Oh my God, I feel under pressure. Oh yeah, let's say you wanted the frequency of 2.5 as well. Remember, the frequency is when you add these probabilities up. So because 2.5 is in the middle of 2 and 3, what we do is we take the frequency, we round down. So we take the frequency of it being less than 2. So we would just add these two together, okay? Okay, normal distribution, chapter 7. Now, remember, sometimes they're trying to trick you. So remember, I always like to write what is going on. So I like to write whatever's happening. X is normally distributed, and what do we have? We have the mean and the standard deviation. So make sure when you write this, you know what's going on, because our z is given, oh my God, sorry, this is supposed to be an x here. Our z is given by this formula. Okay, always write down what you know. You have to do that. And I do suggest drawing the table. Now remember, sometimes we are finding the area. Sometimes we are finding where the number is. So it's really important that you know what's going on. Okay. You know the total area under here is 1, okay? So you know you've got your probability. So if it says 85%, you need to change it to 0.85, you know, like less than 85%. Write down what's going on. Now, actually, I've just figured out how to do all of this on a calculator. So it's pretty exciting stuff, okay? For these ones, you have like 3 typical types of questions. Okay, so remember that, just a bit of a fun fact before we move on, 95% of data lies between two standard deviations of the mean. Okay, the mean is here, right? Okay, so the probability of Z being less than like negative A, for example, is the same as doing 1 minus the probability of Z being less than A. And also the probability of Z being greater than minus A is the same as the probability of Z being less than the positive of that number. Okay, so certain types of questions you have are the ones where you have a set of so many scores are normally distributed. Your mean is 100 and standard deviation is 10. Find the probability of picking a score between 80 and 110. Well, what do you know about this? You know that your 100 is in the middle. Okay. 80 would be here. 110 would be here. Okay, so essentially you're finding your x between 80 and 110, because this is the area that you want. Okay, so now you need to convert them to your z values. And then, so this is the type of question. Now you can go on to your normal commutative distribution, okay? So when you go press 7 on your calculator, go onto your normal, number 2, and then your lower and your upper bounds of these. You can just throw those straight in. Or or find, convert them using this formula and then find the Z tables, from the Z tables. Then also, if you just want to find the probability of x being greater than, like 10, and the probability of x being less than 6, for example, in this, when you put this into your calculator, make sure that you put 10 would be your lower bound is 10, and your upper would be like 10 to the power of 10. And then if you're doing less than 6, your upper in this case is 6, but your lower, put it like negative 10 to the negative 10,000. Okay, that would be easier. And actually upper, you could just do positive 1,000 to positive 10,000. So those are those types of questions. Then the next type of questions that you have are the types of questions where we know that the area is 10% or 20% or whatever, and we want to find the x. So these are like the opposite ones, okay, where you're given the area. What you can do on this one is, again, press 7, but this time, once you go 7, you want to do the inverse normal, okay? Inverse normal for when you click on that, it tells you the area. In this case, our area is 0.1, okay? 0.1 is our area. Or again, you could do the reverse of the formula, the z equals x minus mu over your standard deviation. And then with these, it's just a case of reading the question and making it make sense. I hope that made sense. Right, good luck with S1. Okay, remember when you use a calculator, you do need to show your working. This is the normal one that I was talking about here. If you have an interval, 80 would be your lower, 110 would be your upper. But if not, if you're greater than, make sure 10 is your lower and your upper is 10,000. If you're less than, 6 is your upper, minus 10,000 is your lower. And then the inverse, for the inverse one, this is where you put your area. Remember, convert it to decimal, okay? So 0.1 and then your standard deviation and your mean. And you're all set to go.